So we'll try to do an end-to-end demo of the software development lifecycle. And then when we do that end-to-end demo and then we host an application, our hope is that you'll be able to have the confidence, because that's what you're mostly lacking now, the confidence to be able to sit in on an interview, put in an application, sit in an interview, and be able to talk this software lifecycle that you see and what you are putting as a DevOps engineer in the company. The moment you have this courage to be able to sit in an interview and talk, the rest will follow suit. And I can say this repeatedly that there is no day you're ever going to feel ready or prepared enough. If you like, you give yourself 2 more years to practice DevOps. After 2 years, you will see that it's like darkness, right? You walk into it and you think that you're going to see light, then it becomes darker. That's how DevOps is. When you have covered everything, the software development lifecycle, and you think that you're getting confident, you realize that there are 10,000 other things that you don't know yet. For example, we are still grappling with AWS. The moment you think you know AWS to its brim, you realize that you know nothing on Azure. You know nothing on Google. And what if the company you want to work with in the future accepts that, okay, we'll take you as a DevOps engineer on AWS, but you have to work with Azure. It means the learning curve again restarts. Imagine you learn Jenkins to the end, and then you walk into a company and they're using GitHub Actions or CI. The learning curve again restarts. So it's just something which is always progressive. It's something, knowledge is progressive. There is no way you get to the end of knowledge and say, now I have gotten it. But with the little that you know already, with the little we have done, how do you become a master over it? How do you master it? We have covered Git in this class. We have covered Linux in this class. We have covered Terraform in this class. We have covered Jenkins in this class. We have covered Docker in this class. We have done Kubernetes in this class. We have done a lot of services or a few services on AWS. So of all those services we have touched, which one do you master or which one do you have confidence in? And then next, beside that, I'm going to also give you access to Code Cloud. I bought a Code Cloud subscription. So I'm going to give you access to Code Cloud. And then if you walk around on some of the services that you might touch and start learning on the entire DevOps lifecycle that you might touch and start learning on to be able to boost your way around. So I'll share my screen. There are a few things that we have done. These repositories, you have access to them. So I'm going to share my screen, and then in that process, we hope to build an application and then host that application on an EKS cluster. So the process is this. We have on our GitHub repository, on our GitHub consultancy GitHub repository, we have an application called Retail Store. So this Retail Store application, this is the app here. And then backward, we have the Terraform code to create an EKS cluster. So from this, all we need is this Terraform code that creates an EKS cluster for us. So to be able to get this to our local machine and deploy, I will open, and on my desktop, I will create a folder on my desktop. And the folder will be called, the directory will be called demo. So I'm creating a demo directory on my desktop. And I want to open a new window. I want a new window. So we have a new window, and I want to open the folder called demo. I want to open the demo folder on my desktop. So it's an empty folder. So this is the demo folder, which is an empty folder. And then what we want to do is we want to clone this repository. So this is the repo. We want to clone this repository into our local machine. So I go to the code here and I copy the command to clone. I'm back to our Visual Studio Code. We go to terminal. I have to hit coverage logs. Beside the git bash. And we are in demo, so we run simply a git clone, and we're cloning this repository. So we have the repository clone, and we'll just have a look at what it contains and see if we need to modify anything. So this is it, GitHub repo, and we have Terraform code. This is what we need, this Terraform code. So I can pull this out, and I want to delete these other folders. So I'm deleting this, and I'm also deleting retail store. So all I need, I'm just looking for one thing. The README as well. I don't need this README. And retail store app. This I don't need as well. Yeah. So you see in our demo repository, in our demo folder, we have just EKS cluster configuration. So the first thing is that we have a configuration for a VPC. And that VPC is going to have 3 public subnets, private subnet, as well as 3 public subnets. And it's going to be deployed in 3 availability zones. And we're saying each subnet should be deployed to 1 availability zone for our VPC. And then for the VPC configuration, we're using the default VPC module, which is found online. So it downloads it from online, the VPC configuration module online. So this is just a configuration of our VPC. And then the configuration for our Kubernetes cluster, we have the provider block, which simply states that we're using AWS as our provider. And then for the main.tf, this is going to be the name of our cluster. The name of the cluster is EKS Hilltop. So we can say EKS Hilltop, let's say production. So this is going to be the name of our Kubernetes cluster. And for variables, we have a few variables here. Name of cluster, EKS Hilltop production. And then this is good. Variables main, and this is the EKS configuration. So for the EKS configuration, in our Kubernetes cluster, we want to create a cluster of nodes. Let's use the what EC2 instance size should we use? Let me look at my AWS account and see which EC2 instance size we can use. Go to the EC2 page, and we try to launch instance. So for the instance type, so we can use the T2 micro. Yeah, I think we can use T2 medium. So let's go with T2 medium. So we'll change this to T2 medium. So we'll go with T2 medium as our instance size. And how many instances do we want? our desired, we want to minimum is 2, desired is 2. So we got one minimum 2, desired 2, so we don't have much EC2 instance running. So this is just what we want. So our cluster configuration or our Terraform files are now intact. The next thing to do is, how do we ensure that we are on our AWS account? So how do we ensure that we are on our AWS account? We do an AWS configure. So it provides us this secret key, secret access key, and EU Central 1 output JSON. So we need to verify in our AWS account if we actually have this secret key ID and secret access key, if they are still valid. I don't know, so we need to check. So I go to security credentials, and then secret key access keys. So we have one ending with VI and HH. So this is a VI. So it means it's still valid, EU Central 1. So when you see that our region here is EU Central 1, it means our cluster will be created in EU Central 1. So I have Terraform installed. So we have Terraform installed. So we have to CD into Terraform, which is this folder. I'm doing CD into this folder. So we are there, and we do ls. These are all our files. So we do Terraform format to check the format of all the files if they are correct. Then we do Terraform init for Terraform to start tracking these files. So it's initializing. So you can see here, it's downloading. Look at what it's downloading. It's downloading Terraform AWS module for the EKS cluster. And this is it. Terraform AWS module for EKS. If you look EKS.tf, it's downloading those modules. And there are two modules. Another one is for VPC. So there's module here for EKS modules. And it's also, okay, this is for VPC. These are modules for VPC. If you look at the VPC configuration here, you'll see that we also use the VPC module. So it's downloading the module from the internet. And the second thing it's doing is it's also installing plugins for Kubernetes plugins. So the plugins are being installed as well. So once this is done, we're going to move ahead to, so this is done successfully. So we're going to Terraform is now tracking this file. You see the .terraform directory has been created. And you see the modules. This is the EKS module, the KMS module, and the VPC module. They have all been downloaded from the internet or from the Terraform registry, rather to say. So if we do Terraform validate, we want to validate Terraform. We want to validate this configuration. So it's been validated. We can do Terraform formatted links. No, we don't have that. So we need to plan this configuration now to see if it will be created, to see what will be created. Terraform plan. So let's see what is going to be created if the configuration is applied. So this is what is going to be created. First is It's so many resources to start with, but this is the raw output of what is going to be created. So it's so many things. EKS will be created, VPC CNI, so many things about the Kubernetes cluster. So these are all the resources that is going to be created. But the summary of it is that 44 plan to add 0 to change. So they are simply telling us here that with AWS module, IAM role, Terraform resource, this. So they say a resource is deprecated. Deprecated means that it has been updated. So it says use this AWS IAM role policy. Use the AWS IAM role policy instead. So it says AWS IAM role policy on line 2, because main.tf on line 293. So it says on line 293 in this file, no, main.tf resource AWS IAM role. Module EKS main.tf. So it's downloading from the modules. Sorry, it's rather from here. Modules EKS main.tf. So it should be here 293. Yeah. So it says we should rather use IAM role policy. By changing that IAM role, let me see if it works. So it throws us many errors. So many things will go wrong because we need to change it in so many places. To Control Z, but either way, this will still work. So we'll go ahead to create the resource on our AWS account. So it will be Terraform apply dash what is it, auto approve. So this will take a while. While it's creating this resource, we'll look at something else. So this one will simply create a VPC for us and create a Kubernetes cluster for us. So these are the two things that we expect to get. And then besides this, if you go back to our GitHub repository, there are some projects that we had worked on together in this class. So with this repository, we are done with this repository. All that we needed from this repository was this Terraform file. So we are done with this repository. So if you go back again into our GitHub, there's a folder we had worked on in this class, which was the color app. Color app. Not Musango. Yeah, color app. This is it. So this is the color app that we have deployed. And for this color application, it's simply a Node.js application that simply displays different colors depending on the color that you input. So if you go to index.html here, you'll see that the application will simply say, welcome to the color display app. The current background color is, so the color, whatever color we put, in our Docker file will be the color that will be displayed. So this will be the color. Whatever color we put here will be displayed on our application. Then you have a few text here in the application. It displays the time and the month. So this is the first thing to note. Then we have the package.json, and then we have app.js here. And for the app.js, a few things are defined in the app.js. We are going to have the port of this application running. To access this application, you need to access it on port 8080. And then the environmental variable, we have put a default color, meaning if you don't define a color, the default color, so this is going to be a constant. Like the default color will be red. If you don't put any color, red will be the default color. And then you have the footer of the website. So this will be the footer of the website. And that is that. And then you have the README file that simply gives you the steps how to use the application. And then more importantly, you have our Docker file. So if you look at our Docker file, we are saying in our Docker file that the default color will also be red here. And then you can pass in, you can override this default color by putting an environment variable to your application. So if you use an environment variable, it will then use this, whatever color that you specify, whether blue or whatsoever. And then the application is also exposed on port 8080, and this is the command that starts the application. So that is that. So we're going to, our AKS is still being deployed. So what we're going to do now is we'll pull this configuration into our local desktop. So this color app, we're going to pull the color app configuration. So I copy this. And since our EKS is still creating, we will not stop this process. So what we'll do is we'll open a new window. So when we open a new window, of course, the previous window is still running. So this is the previous window, it's still running. And we'll go to open folder, and then we open that same folder, which is this demo folder on our desktop. So this is the demo folder. So this is the demo folder. Let me see. Open folder, demo. So you can't open the folder because it's active now. So we'll just create another folder called color. We'll call app. So we're going to open the app folder. Open folder, and we'll open app folder. This is it. I just want us to be doing something else while this is creating. But if you want to see what is happening already, so this is the app folder, empty, nothing is there. If you want to see what we are doing already, if you go to our AWS account, and the region we selected for VPC was Frankfurt, EU Central 1. So VPCs, so you see there are two VPCs now. Can you see our VPC? This is our VPC, the VPC we just created now. This is the VPC that we just created now. And this is the configuration. Remember how many subnets did we ask for? We asked for, if you look at our configuration here, when we are creating our VPC, if you go to VPC configuration here, you see that we requested for 3 public subnet and 3 private subnet in 3 availability zones. So that's just to confirm that here, that we have EU Central 1A, B, and C. So this is 3 subnets. This is 3 availability zones, EU Central 1A, B, and C. And then look at the number of subnets. Look at private subnet. How do we know private subnet? Private subnets are the subnet that have the NAT gateway. So this is it. EKS, top, prod, private. So these are all private subnets. And then these are public subnets. So we have 3 public subnets, 3 private subnets. And then we have the 2 route tables. These are our route tables. And then this is the internet gateway to the public subnet. And then this is the NAT gateway. So this is how it works. And then for EKS, let me see what state EKS is on now. So this is our EKS cluster. It's still in creating state. So once the EKS is done creating, you go to compute and you see that it will add nodes here. So I know the EKS normally takes some time to get completed. So while it's going on, we'll patiently wait for it while we do something else. So we needed to clone our repository for the application into the app folder. So this is the app folder, which is empty. And then this is the repository for the app folder. Yeah, color app. So let's clone that repository. So it's git clone. So we've cloned successfully. And let's look at the content of our repository. We have the color app and then the app.js, which is exactly what I was explaining to you. So this is the app.js containing information about our repository. We also have the Docker file containing information on the build information. We have the index.html as well. And then we have the package.json. And then the README file, which is just an instruction on how the steps to use in building the application. So if you're not so sure, we can follow the steps from our GitHub repository. Exactly what it says, how to use the application. So the prerequisites say download Docker. So you need to have Docker running. You also need Git, and then you need Kubernetes here, like kubectl. So I'll run Docker to see if I have Docker, and I already have Git. I'll run see also if I have kubectl running. So what I then do in that case is I need to test all of this. If I have all of this running. So if I do Docker, so Docker is running, and then kubectl is also running. While doing this now, I'm going to start my Docker desktop. So since we have the app, ls, this is the next step as per our repository. The first thing is you clone the repository. I made the steps very explicit. You clone the repository. We have just done this. Then you cd into color app. So after you cd into color app, you can then do your Docker run to be able to build the application. When running the application using Docker, the application inside the container always runs on port 8080. However, we use port mapping -p port host port to port 8080 to expose different color versions on different ports. So this is the step. We'll do Docker run -d-p port 8080, then color app, then the version is red. So it maps it on port 8080. But before we do this, we need to first of all build the application. Okay, we need to do our Docker build. We need to build the application before we run it. So the first thing is, let's build this application. So we're doing Docker build And the color we want to use here is the color red. And this is the name we are giving to the application, Hilltop Consultancy Color App Red. Before we put this, remember, let me check, no, Docker Hub. We're going to use Docker Hub in this, our practice. Let's see. So we're in our Docker Hub account. And if you look at our Docker Hub account, we have repositories. So this is our repository. These are the number of repositories that we have. Color app, Musango, no Rainbow app, Color app, Docker, Bank of America app, Terraform app, Nodejs, and all of this. So let's create a new repository and call it multicolor. So this is the name of our application, multicolor, like this. So you look at the tag. So the tag will look like this, Docker tag, then repository, local image name and tag. So we are creating a new public repository. So our repository has been created, and this is how it's called, like this, tag name. So we can still call it multicolor app or whatsoever, but this is the name of our repository. So let's try to do a Docker build using this command. Docker build, then the argument. This is just like environment variable. We want the first color. This is the first color. We want the first color to be red. And then the tag, whatever tag we put here. So we copy this command for Docker build. So this is completed. It says the creation of the cluster was completed. So this is nice. Since this is completed, I'll clone that repository here again so that we have everything in one place. This repository, I'll clone it in this directory so that we have it in one place. So let me close this. We don't need this anymore. So CD one step backward, ls, Terraform, then I'll do git clone, and I paste it here. So it's been cloned here. So we have all of them, Color App and Terraform in one place. So I'll do CD into Color App, ls, we have all our files here. So the command we want to run is the Docker build command to build this, to build our Docker image. So it's Docker build -tag. And then we need to provide the tag. And the tag here, the reason why we're using this tag is because we have created the repo. If you don't use this tag, you'll not be able to push to this repo. You need to come and tag again. So we'll copy it like this. So our tag here, can call this version 2.0. Okay, version 2.0. Let's say this is our version 2.0. So the first one here is the username. Okay, this first one is our username, the username of our Docker Hub. It's very important to remember this. This is the username of our Docker Hub, Hilltop Consultancy. The second one, multicolor, is the name of the repository. This is the name of the repository. Then the third one is the tag that you're giving to, or the version you're giving to your image, the Docker image you're building. So we can use this, we can either call this red 2.0 to since we're building the red image. So we can call it red 2.0. So I do my Docker build. It says we didn't provide the Docker file, so we need a dot. If I don't provide this dot, it's not seeing which file to build from. So we need to provide a dot to say build from the Docker file. So it's building now. So it has built successfully. If we do Docker images, we should be able to see the Hilltop Consultancy multicolor. This is our tag, red version 2.0. So this is the image we just built now. This is the name of the repository. Remember, this is the repo, and then this is the image tag. If I do Docker PS, we still have this running. This is an application I had deployed a long time ago. I wasn't even sure that it was still running. But anyway, that's fine to know that it's still running. So we have this Mongo database running. So this is now just a Docker image, okay? At this point, we just have a Docker image. Docker images. We just have a Docker image. It's not yet a running application. What did I say a Docker image is? A Docker file, let's start from a Docker file. A Docker file is simply a manifest file containing the source code, the run instruction, the environment, and other environmental variables that are required to build a Docker image. Then what is a Docker image? A Docker image is a compiled version of a Docker file. So the application source code, its dependencies, and every other requirement is being compiled to run the application. Then to have the running application, we call it a Docker container. And what is a Docker container? A Docker container is a running instance of a Docker image. So how do we turn this image into a running instance? How do we make it to be running? So that we can access, because now you cannot access it over the internet. So how do we make it running so that we can access it locally? This is to access it locally. To have it running, we go to our repository and see what it says. Our repository says that after building this Docker image like this, building the Docker image with different colors. So we have built our Docker image with the red color. How do we run it now? We can do Docker run -d, meaning in detached mode, so that it should run in the background, and then -p for port forwarding. And we say all traffic on port 8081. Remember, I said, what is this first port? This first port 8081 is host port. And what is our host in this instance? Our host is my machine. It's my local laptop on which I'm running this command. So I'm saying my users should access my application on port 8081 on my machine. Remember, we're not using any EC2 instance as of now. We're just testing it locally. The moment we test it locally and we are sure of it, we're then going to run it on the server. So on my server, on my machine, I'm saying that access this application on my local laptop. The moment the traffic comes on port 8081 on my local laptop, Docker is then going to redirect that traffic to port 8080 on the container. Remember our container here on our Docker file, we have said it should run on port 8080. If you look here in our Docker file, you see it that it was specified that it should run on port 8080. If you also check the app.js, you see that the port was defined to be port 8080. So here we need to run this command, the Docker run command. So since we are building for the red app, we'll just copy this command for Docker run. Remember, we cannot use this part because our repository and the username is the same, but the repository has changed and the tag has also changed. So we just need this part. So we come to our VS Code and we take the Docker images command just to have it. Then we paste the Docker run. And then it's going to be this. And then map to, this is a new tag. Like this. So when we run this command, it's going to help us to be able to access our application locally on our laptop. So it has been built. So if I do docker ps now, can you see that our application is running? This is our application. This is the image. Hilltop Consultancy Multicolor V2. And it says all traffic from the internet, this all traffic hitting our machine on port 8081 is forwarded to port 8080 on this container. Before I even go to my browser and check if it's running, I can come here. We have a command that helps us to see the logs, except that I did not put it, but there's a docker log command. I did not add that command, but the command is docker logs, then the container ID. So this is the container running, and then this is the container ID. So if you do a docker log, and then the container ID, what do you see? Hilltop Consultancy Color display application. This is the address, and then server has started. The background color is red. Hilltop Consultancy contact, and this is the logs that we get from the application. So it tells us that the application is running on this link, So let's copy this link and go to our browser and see if it's actually running on this link. So on our browser, we paste the link and hit enter. Site can't be reached because what do we need is port forwarding. Sorry, it should be 8081. Localhost 8081, not 8080. Because remember the steps that I said here, it should be 8081, not 8080. This is the error. It says all traffic coming from the internet hitting our machine on 8081 is being forwarded to 8080. So it has to be 8081 forwarded to 8080. So this has to be 8081 rather. Do we have our application running now? So it says, welcome to the color display app. The current background color is red. Welcome to Hilltop Consultancy Color Display Application. Address, Sulen 3, Copenhagen. Website, then contact. Then we have today is Wednesday, March 26, 2025. This is 7 p.m. And you see the website is streaming the time live, the countdown. So we have successfully had our application displayed and running. Now, this is the red color app. What if we wanted the gray color app or the purple color app? What do we do in this scenario? We can do the same steps. We can simply come here and use the same command to do the Docker run. Since port 8081 has already been occupied by the red, we'll change it to 8082. Remember, our container is running on port 8080. This 8082 is the port on our local host, my own computer in my house here. Then I want to change this tag to, let's say, which color can we use? Which color should we use?
Blue.
Okay. So let's try blue, version 2.0 for blue. So let's run the app for blue. So it says that no, this is Docker run. We need to build first. Sorry, we need to do a build before we run. So this is build. So this is blue now, and then we change the env here to blue. Remember, in our Docker file, very important for you to note. Remember that in our Docker file, what was the default color? Red, right? Look at our Docker file here. The default color in our Docker file was red. But we say by way of env, which is what we are doing here, the env of color is going to be this value, color. And this is why we're saying color here is going to be blue. So this is how we change it to blue. This is how we change it to blue. And there's something just to now verify. If you look at where the logs, where we get these logs from, the logs that I just displayed, the logs are coming from here. This is where we get the logs from. Which says Hilltop consultant color display application, which says the current color. This is it. Replace color, background color. So this is the log message. Current color is background color. So now when we run this application, client IP user agent running on port localhost, then port number, and then background color is Hilltop consultancy contact. So this is going to be the logs that we get when we run our application. So current color here, we have changed it to blue.
Grow and feel supported. But after what happened to my twins, I don't think I can trust the system again. My 8-year-old twins, Lily and Noah.
So let's try to build a new Docker image.
That all changed when they got a new teacher this year.
Blue.
I didn't think much of it when they came home a little sad. But then small comments.
We have built a new Docker image for blue.
Handwriting in front of the class, telling everyone it looks like a toddler scribbles. Lily.
So if I do Docker images, we now have blue, right? This is blue, the blue version of that, our image running. So for us to now create a container out of it, we'll do Docker run and then blue on port 8082. So let's do our Docker PS. So here you see that all traffic coming on port 8082 is still forwarded to the same container, which is our blue application. So this all traffic from the internet sent to port 8082 is being forwarded to port 8080. So how do we access the blue application? We simply do the same thing that we did here, localhost 8081. So here we're going to do localhost 8082. Do we have the blue version of our application? This is the blue version of our application running. So if I check the logs here, if I do Docker logs and I copy this container ID of the blue application and I do my Docker logs with the container ID, what do I get? I get the current background is blue. So this is the current background I get, blue. Does that make sense?
Yes.
So this is the current background I get from this application. It's the blue application running. Okay, now, since we have our application running, any question at this point? Is there any question at this point?
Not from me.
Okay. So we have the blue application running. With the blue application, what can we achieve? So it means at this point, we can virtually build, several colors. Okay, we can virtually build several colors without stress. I can turn this to green. Okay, we can build a green version of our application. And I just change the color here to green. So I'm building another version of the application for green. Easy peasy, it's been built. How do I run the green version? So I simply change this to green. And
8083.
8083, yes, that's right. I simply just change the port. Remember, this port 8083 is the port on my machine. So it's been built. Now, if I do Docker PS, we now have the green running, and this is the container ID. Can we check this? We'll do a Docker logs with this container ID. Can you see the version here? The color has been changed to green. So how do I access this? I access this by simply copying this same URL and then changing it to 8083. And we have green. So you see, we have dynamically been able to change our application from red to blue to green. And we can keep going. Now that we have our application running, this is the first step. The challenge we have at this point is the ability to scale this application. Because if this was a dynamic application where you have multiple users sending in requests to this application, the application will not be scalable. So we need scalability of this application. We need high availability of this application. We need it to also be reliable and fault tolerant. Because if something happens by error to this our application, if something happens to it by error, the entire application goes down. If something just happens and stops this Docker image or this Docker container, the application goes down. So we need a method that ensures scalability of our application. And how do we attain or achieve scalability of this application? That's why we now use the concept of container orchestration. So with container orchestration, we're going to use Kubernetes as a container orchestrator for this our application. We're going to use Kubernetes as a container orchestrator for our application. But Kubernetes is going to only make use of this our Docker containers or Docker images from a Kubernetes repository or from a container registry. That's why Kubernetes has container D. And container D is the software that helps Kubernetes to orchestrate Docker containers. So for us to do that seamlessly, we need to push this our Docker image into a Docker registry. So since I have my Docker desktop running, I'm already automatically logged into my Docker hub. So if I do Docker login here, the command is Docker login. You see that I'm already authenticated. It says login succeeded. So I'm already logged into my Docker hub account. So what is the command to push this our image into our Docker hub repository? If you come back, the steps are also here, pretty easy. The step will be to do Docker push, and then the username, the repo, and then the tag. As easy as this. So what are the different image tags that we have? Remember our repository, this is our repository, Ethos Consultancy Multicolor. So if I come back here and I do Docker images, so these are the 3 images that we have. So the command will be Docker push, and then I simply just copy the repository, which is this. Then I copy the tag for green. So this is for green. We need a colon here. So this is for green. I want to push the green. I hit this. And this is a Docker push happening. Ethos pushed. I'm seeing Ethos Consultancy / Musango. Where did you get that from? Multicolor green. Let me see. Refresh and see if that push was successful. So this is our push, right? Green. So we have the green version already pushed. If you go to this stack, so these are the layers. App.j expose 8080. ENV color was set to green. So we set our ENV color to green for this particular green app. So this is the green version pushed. If I want to push the red version, it's the same command. I just have to run the same command and I change this to red. So I'm pushing multiple versions to the app. So I can put for the red to be 3.1 for red. No, it has to refer exactly to what we have locally. To look at something, pushing for the first time, you have so many pushes going on, it takes a longer time. But pushing for the second time, it says all of these layers already exist. So it doesn't do it again. It just use the one that already exists. That's an advantage with Docker because Docker uses caching. And you see the version here is green, the version here is red, and then we'll change it now to blue. I think these are the three we built, right? So we have pushed 3 versions. We can check up those 3. We should be able to have 3 tags now. So you see our tags, right? We have 3 tags now, green, red, blue. So I've successfully built and pushed 3 images to our Docker repository. Now, what do we then do? How do we then run these applications? Or how do we then orchestrate these containers? To orchestrate these containers, we make use of Kubernetes. We have created an EKS cluster. I don't know if it's active now. So our cluster is active, and we have 2 EC2 instances running. This is our Kubernetes cluster. Hilltop, EKS Hilltop prod is active. And then we have, for the nodes, if you go to compute, you see we have 2 EC2 instances running, ready 29 minutes ago. If you go to the EC2 tab, instances, we should have, okay, this is an old instance I have created. So these are the 2 EC2 instances that we now have created by our Kubernetes cluster, T2 medium instances, which are up and running. So you can see EKS top prod. So this is great. And then what we now need to do, let me see. Yeah, no, good. So what we now need to do is to connect to this Kubernetes cluster. How do we connect to this, our Kubernetes cluster, to be able to deploy resources? What's the command to connect to our Kubernetes cluster? So the command to connect to our Kubernetes cluster is AWS EKS update kube config, and you put dash name. The name of our cluster is EKS Hilltop prod dash region. What's our region? EU Central 1, right? So this is how we connect to our cluster. So it says the kube config has been added. So when you look at when we put AWS, this is the ARN, the context ARN. It gives us, when you see this, look at the cluster, the account ID. This is our account ID, ending with 80. Can we confirm if our account ID ends with 80? Does it look like our account ID? So that's how you know we are connected to this cluster. So if I do kubectl get nodes, just to be sure that we have our two EC2 instances running. Can you see we have our two EC2 instances running? Those are our two EC2 instances running. Now, since we have our two EC2 instances running, the first thing to do is we need to deploy our application on this Kubernetes cluster. And to do that, we are going to create a new directory here called Kubernetes. So in this directory, let's start by creating another directory called pod. So we'll do it gradually. And in the pod directory, we'll create a file called pod.yaml. So in our pod.yaml, we want to do the configuration of the pod. So we'll just do pod. So it gives us the Kubernetes pod configuration. This is the Kubernetes pod configuration. And what is auto-populating this for me is because I have this extension called Kubernetes. So this is the Kubernetes extension that I have. If you don't have that extension, you can come to extensions here and you search for Kubernetes. So this is it, Kubernetes. It auto-populates it for you. So I already have that. So it gives me the configuration of a pod. So the name of this pod, I'll call it multicolor app. So it's our multicolor app. Now, for Kubernetes, you have labels. Just like you go to a supermarket and they put labels on objects, we have labels on Kubernetes. So what is a pod to start with, if you have forgotten? A pod is a single running instance of an application. Okay? A pod is simply a single running instance of your application which is deployed on Kubernetes. So just like we did it locally on our laptop here with Docker, and we had one instance of our application running, we can run a pod, and the pod will simply give us one instance of our application. The problem with using a pod, because a pod will simply give you almost the same capabilities as using Docker, just Docker. But when you use a pod, if the pod is killed or if the pod fails, it cannot be recreated. It also dies, the container also dies as well. Just like if your Docker container stopped, then your application also goes down. So with a pod, what we need to specify the name of our container. So we can give our container a name called multicolor app container. It doesn't matter. You can give it any name. What is more critical is the image that you put on your container. So when you give the image here, this image must be an existing image in your repository. So look at the description of an image. Container image name, more info. So we need to add the name of our image. So we go now to our Docker Hub, and let's say at this point, we want to deploy, say, the green version of our application. What do? So we copy just the image tag like this to deploy the green version of our application. So I simply replace this image with the green version. So it's going to deploy the green version. Now, it has some resource requirements here, which at this point, we actually don't need a resource requirement. This resource requirement is simply stating, let's say, to guarantee the memory that this pod or this container needs to run, that's when we put a resource requirement. And in Kubernetes, this concept of resource requirement, where we put the limits, the CPU requirement, the memory requirement and limit, CPU requirement and limit, is called quality of service. You can look at this more. It's called quality of service. But now we don't need this resource requirement now. Then we need the container pod. What was the container pod of our application? Anybody? Pardon? Port 8080. So this our application runs on port 8080. So now that we have this configuration of a port, how then do we expose this application? To be able to expose this application, if we do ls, we need to go one step backward. Then if we do cd into Kubernetes pod ls, we have the pod.yaml file. This is the file we are about to deploy. The command to deploy the application will be kubectl. When you see me write K, it's an alias, because if I put aliases, I don't know if it's aliases or alias, alias. These are all the aliases I've defined. So my K stands for kubectl. Kubectl apply is K apply. So these are some of the aliases that I have. So if I do K apply -f, then the name of the file will be pod.yaml.
The old alias.
Pardon?
The alias is it by your chosen?
Yes, it's my choosing.
Okay.
Yes. So this is the full command. The full command is supposed to be kubectl. The full command is supposed to be kubectl apply. The full is supposed to be kubectl config current context. So for example, if I want to run this full command, it will be kubectl config current context view like this. So this is the current context. But if I want to run it again in the short form, it is kcf. Kcf. It gives me the same output. So alias is a shorthand. It's making use of shorthand as we commonly call it. So our command here will be k apply -f pod.yaml. So I want to create the pod. So multicolor app has been created. So if you look at the aliases again, we should have an alias for kubectl get port. So this is kgp for kubectl get port. So I'll just do kgp. Can you see we have multicolor app pod running? So the pod is running. So if I want to get the logs from this pod, it will be kubectl logs. Then I put the name of the pod. Can you see the same output we got from Docker? Do we have that same output here?
Yeah.
You say we don't declare.
Yeah, I see.
So we can see our application is running and active.
It's running. Yeah.
Yes. So how do we access this application? Now, this takes us to another concept in Kubernetes called the concept of service discovery. Remember, when we're using Docker to access our application, we had to do the Docker run command. Okay, we had to use the Docker run command to have access to this application, which was this, the Docker run command. And this -p was where we declare the ports on which our application should be accessed. And that's where we use -p, and we specify that all traffic coming to port 8083 should be forwarded to port 8080 of our container. So this is how we expose this application, by putting this -p. But the concept changes a little when you come to Kubernetes. In Kubernetes, we use service discovery in Kubernetes. And there are 3 types of service in Kubernetes. apparently 4, but most use is 3. So there is the service of type cluster IP, there is a service of type node port, and there is a service of type load balancer. What are these services and what is the use case? A service of type cluster IP is a type of service that exposes the application or the application deployed or the port within the Kubernetes cluster. What does this mean? The use case is that this type of service is intended to be used for applications which are not purposed to be accessed externally. So if you have an application that you don't want it to have access to external communication from, say, the internet, like a database, then you can deploy that application using or a database or a backend application. You can deploy it using a cluster IP. In that way, it will only be able to communicate with other ports or other resources within your Kubernetes cluster and not out of your Kubernetes cluster. So that type of service is not very useful in this scenario because we want our application to be accessed out of our cluster. So what then do? We go to the next type of service. The next type of service is called service of type node port. What is service of type node port and what is the use case? The service of type node port is the type of service that is intended to expose your Kubernetes application on the node of your instance or the node of your server. This service of type node port is the same concept of using the Docker expose, where we put Docker run-p. Because when we did Docker run-p, it was using a port on our machine, on my local machine, to expose the application. But this time around, it is going to be using a port on the EC2 instance of our Kubernetes cluster. It's going to be using a port on the EC2 instance of our Kubernetes cluster. So how do we achieve that? So we're going to create another file here called node port svc. So we can put svc. SVC stands for service.yaml in short form. So we're going to create a service here, Kubernetes service. So this is it, Kubernetes service. So we have one that gives us the 3 types of service. Let me see. Service, kube.service or Kubernetes service, not this. Let me see kube.service, not kube.service. Service complete. Yeah, service complete. So this is the example that I'm looking for. So if you look here, the kind is also service, API version v1, the name, we can give it a name. Let me save this and then open on the site. Open on the site so that we can look at the port and look at the service. Now, for this service is created with the intention to expose this port that we have created, and we know our port is running already. Now, the name of our service, we can call it multi-app service. So we'll call our service here multi-app SVC. So this is going to be the name of our service. A key and very important component, please follow up closely, is where you have the spec. What is the specification of this service? For the spec, you have a field called selector. A selector field is very important. A selector field simply means you have a big bowl and there is all sort of objects inside. And you want to magnet all the objects that are iron objects. So when you bring a magnet is going and you hover that magnet over the bowl, the magnet is going to be looking for all metal objects to be able to magnet it. If you have objects like rice or some other grains, since they are not metal objects, they will not be magneted. This is what the service is doing. Same example. A service, this particular service is going to come in the Kubernetes cluster, and it's going to find several ports running. Then it brings its own magnet.
If you want to count, you count here.
So it brings its own magnet and is scanning within the Kubernetes cluster on all the ports. Which of the ports have I been sent to magnet? So when it comes, it's going to have a label. This selector field is going to be looking on the labels. On the label of the port, we get a label called name, which was equivalent to multicolor app. In the same way, the selector field of your service is going to be looking if, for this default one, it has app equals to select label. So it's going to be looking among all your ports. Which of your ports have app equals to select label? It wouldn't find it. So we need to make sure that our selector matches the label here. Otherwise, this service will not be able to expose this application. So that's why we have to cancel this and replace this with name equals to multicolor app. This way, when our magnet is hovering over all the ports, it's going to find a port that matches it. So when this service finds a port that matches it, it is then going to expose this port over the internet. Not this, Control Z. So is this label is going to be name equals to multicolor app. So this is how this selector fields identify the right port to expose. What is the type of service that we want? We want service of type node port. Remember, I said we have three: load balancer, cluster IP, and node port. So we're going for the node port type of service. Node port type of service. And the name of the port, we can simply call it TCP. And then now you're going to see two things, very important, not to forget. We have port and we have target port. Who knows the difference between port and target port in this scenario? Who can tell me the difference between port and target port? So port refers to the port on which this service itself is running. Port here, port 80, which is the first port, is the port on which the service itself is running. Then what is target port? Target port is, what was this service created to do? This service was created to expose a container called multicolor app, which is carrying this image. And that container is running on port 8080. So target port is simply saying, when you go to expose this application, which we have it in the selector field, you're going to be finding this application at the target called 8080, which is this container port. So target port must match container port here. This is the first thing. It doesn't end there. We have the next, which is node port. Written like this: node port, small n and capital P. And your node port simply means which port on your server or on your Kubernetes cluster or on your EC2 instance do you want this application to be running on? And what did I say was the node port range? Can anybody remember what the node port range was?
32,600.
30,000.
30,600. Yeah.
Kubernetes node port range. So
Yeah.
this is it. 30,000 to 32,767. So we need to pick any number within this range. So we can pick 31,000, let's say. So we pick a port like 31,200. So this is going to be our node port. Then I save this configuration. So we're saying on our EC2 instance, this application should be running on node port 31,200. So what will happen by default is that when traffic is coming from the internet to access our application, just like we had it on Docker, that traffic is going to first of all have to hit our EC2 instance or our server hosting the application. And when it hits our server, it has to come through port 31,200. The moment it goes to port 31,200, that traffic will therefore be forwarded to port 8080 on our container. So this is how we are going to gain access to this application. So to apply that, we are going to do kubectl apply -f. -f means file, and the name of the file is nodeport service.yaml. So the service is created. If I do to get the service is kubectl get svc. You can spell it service in full if you want. So this is the service. So what do you notice on the service? The service is called multicolor app service, and the type is node port, and the cluster IPs is this, external IP, no external IP, and it says, if you look at describe, kubectl describe SVC, multicolor SVC, you will see that for the multicolor SVC, it's running on TCP 31,200. Now, how do we then access our application? It provides us an endpoint here to the application. What is this endpoint? Look at the endpoint. Key to note. It says all traffic that is going to come to this application is going to end on this IP address mapped to this port 8080. Let's look at this IP address. If we are going to find it, where does this IP address come from? 10.42.127.157. If you do kubectl get ports, just to show that the selector selected the right port. If you do kubectl describe port, look at the IP address of this port. Come up here and see the IP address of this port. Look at the IP. 10.47.127.152. Does this IP resemble the IP that we saw on the service, describe service? Look at the service. Look at the IP. 10.42.127.152. Same IP that we have here. 10.47.127.152. So this is the IP address of this port, and the endpoint here simply says that the traffic that is going to come to this service is going to end up here on this port. And this 8080, does it ring a bell? This is the port on which our application is running. So how then do we access this application? We said this application is running and is exposed to port 31,200 on our EC2 instance. So to access this application, let's go back to AWS. So if you go back to AWS and we get the instances that are running, these are the two instances that are running, which are part of our Kubernetes cluster. And then let's look at the security group attached to these EC2 instances. So this is the security group attached to the EC2 instance. Look at the ports that are open on this security group. Edit inbound rules. So you see, it uses this security group to expose the application. But now, beyond that, let's try to access this application and see if we can access the application. So we need to copy the private IP of this application. Let me see. Map to let's see, map to 31,200. So it shouldn't give us any access. This shouldn't give us any response because this port 31,200 isn't open on our application. Another reason why we won't be able to access, even if we open this port, let me go on the security group and try to open this port and see. So this is the security group, and I want to edit inbound rules, and I'm adding custom TCP port on 31,200 to allow traffic from everywhere. So allow that port. So this is the security group. So open that port on our security group. Let's see if we're able to access. So we're still not able to access this application on that port. This is the endpoint. We can't access it from this endpoint because this endpoint is within the cluster. This endpoint is within our cluster. So we cannot access this application. And the reason why we can't access this application because the cluster that we created did not have a public IP address. This our Kubernetes cluster did not have a public IP address. And if you look at the configuration, something that we missed out, we should have done this, but we'll try to access it differently with the load balancer. If you look at the Terraform configuration, or the VPC configuration, sorry, enable NAT gateway through internet gateway, hostname. These are enabled. Look at the EKS configuration. Workshops for create cluster security group first, create node security group first, network policy. Why don't we have a public IP address? Public subnet prefix. Oh, of course, probably our instances are in the public subnet, maybe in the private subnet, which is probably why they don't have. Let me look at the subnet ID. So this is private subnet. So our instances are deployed in the private subnet, and that's why they don't have a public IP. That's why we can't access this application because they're in the private subnet. Let me look at the other instance. It's also deployed in the private subnet. So that's why we can't access it. Let me see. We can definitely use a load balancer in the next example to access this application, but I will try to see. Now we need a jump server. So this is the first scenario, but we're not able to access our instance because we don't have the public IP. All the instances were deployed in the private subnet. Let me see. VPC main provider main.tf EKS management group instance version. What we can do is let me add another instance and see to the auto scaling group. To do this, we can also automate that process here to add our EC2 instances to be, let's say, 4. Just want to add the instance to be 4. City and CD into Terraform. Minimum size desired 4. So we do Terraform apply. Terraform apply. We just want to add an EC2 instance. 0 changes added, 0 destroyed. EC2 medium. It's not being added from here. But let me see. Let me add this to 4. So I want 4 EC2 instances. I just want to see if the reason why 2 were deployed, so initializing, and this goes to private subnet as well. Probably this doesn't have private subnet. No, this doesn't have. So this doesn't help. We'll simply just use a load balancer in the next example. So we'll just use a load balancer to try to access the application. So, but of course, we can do the logs here and see that our application is accessible. kubectl logs, multi. So we know that our application is accessible from here. And to access it internally, you can do curl localhost. You can curl this localhost 8080. Now it will be 8 localhost 31,200. Get SVC. 21,200. Use it here. Describe SVC multi-column. Let me do current. So we don't get a response, but kubectl locks. If you lock the container, multi-container, we know that our application is running, but we can't just access it externally because we don't have a public IP. But we'll try to see if we can create a load balancer and access it with a load balancer externally. So we'll create a port here. Then we'll create another folder. Called deployment. So within the folder, we'll create a file called deploy.yaml. So within the deployment file, we want to create a deployment. So Kubernetes deployment. This is more than we need. Kubernetes deployment. Kube deploy. Also more. Kubernetes deployment. This is basic. This is what we need. So for a Kubernetes deployment, we can do the same thing for a deployment. What is a deployment? A deployment is simply an object in Kubernetes that offers you the possibility to have multiple replicas of your application. So you can have multiple replicas of your application running at the same time. Unlike a pod gave us only one instance. So you cannot have multiple instances of that pod running. But if you use a Kubernetes deployment, a deployment can give you multiple instances of that pod running. So we'll simply call this multi-color deployment. So this is our multi-color deployment. And then the app for the label. Remember where we use matching labels as well. App is equals to multicolor. We can leave it as multicolor. Then up here, it must be the same thing. This is how we put the label. Remember, we are going to use this label when we're creating the service. And container name was multicolor container. And then our image, the image that we used, we can use this one as again. So we replace this with the image. And then for memory, all of this not required now. For ports, we simply use our container port 8080. But now, where do we then specify the replicas? To specify the replicas, we simply add a field here called replica, and then we specify we want 3 replicas. So this will create 3 ports for us for this application. So let's try to apply that. So ls, we have deploy, kubectl, apply, -f, deploy.yaml. So the deployment has been created. Kubectl get deployments. So you see, we have 1 out of 3 is ready. Ready is still 1 out of 3. So 3 out of 3 is now ready. Let's see the port. Kubectl get ports. So we have our 3 ports running. Remember, this was the first port that was created by a pod. We created this one using a pod. That's 32 minutes ago. But these other 3 have been created using a deployment. Now look at something. Let's try to delete this one ending with G. Let's delete this port and see ending with G. kubectl delete port. So the port ending with G has been deleted. So we expect to have just 2 ports running from the one created with a deployment because we've deleted the one ending with G. So let the process get completely deleted. And then we list our ports again to see what happens when we use a deployment versus when we're using a port to deploy our applications. So kubectl get ports again. So you see, instead of 2 to be left, we have 3, meaning there was this one with K. We didn't have any port with K, right? Look at, it's been created 36 seconds ago. So a deployment offers the possibility for our ports to be recreated. Why is it being recreated? If you do the kubectl get deployment, you see that in our manifest, we have requested for 3 replicas. So it says 3/3 ready, up to date 3, available 3. So the moment you request for any number of replicas here, your deployment is going to make sure that through a replica set, so if you do kubectl get replica set is going to make sure that 3 replicas, this is desired. So we desire 3, current is 3, ready is 3. So the moment you create a deployment also creates a replica set in the background. And this replica set is the one in charge of monitoring these ports to make sure that at any given time, 3 ports are running. So that's the function of a replica set. And by doing this, we are ensuring high availability of our application. So not only is our application highly available, our application is fault tolerant. Because if a replica goes down, another replica is recreated. But look at this port that we deployed without using any configuration of a deployment. If I delete port and I delete this port, multicolor app, this port by no means is going to be recreated. It's not going to be recreated because there is no replica set managing it. So the moment you deploy application in Kubernetes, you must ensure that those applications are fault tolerant by using objects in Kubernetes like a deployment. Now, we have seen a couple of objects in Kubernetes, which I'll just recite here. Beside a deployment, we have if I do kubectl get port now, you see it's just 3. That one has not been recreated because it's not managed by a replica set. So we have seen a deployment, we have seen a port. There are other objects in Kubernetes like a daemon set. What is a daemon set? If you do kubectl get ports -oy, you will notice that on those ports, they are running on different EC2 instances. Even though we have kubectl get nodes, even though we have how many nodes here? We have 1, 2, 3, 4 nodes, and the IP addresses of the nodes are ending with 177, 29, and 16. So you see that this port is not carrying, or this node is not carrying any port. The 3 ports are spread across. Now, if you want to create a daemon set, you don't need to come and specify the number of replicas here. What a daemon set does is, a daemon set will ensure that for the given number of nodes that you have, it is going to create an equivalent number of ports. So it will be 1 port per node. What is the use case of a daemon set? A daemon set is useful if you want to deploy applications like log scrapers or some monitoring agents. So it will ensure that each node is carrying one of those ports so that it does specific function on that specific node. Another use case is replica set. A replica set is also an object in Kubernetes. But for a replica set, it ensures that all your objects are orderly created, they are orderly destroyed, they follow a particular order. Sorry, I'm talking about a stateful set. So a stateful set will ensure that the name of your objects are maintained, they are orderly created, they are orderly destroyed, and the most capability of a stateful set is that it maintains its state. What do I mean by it maintains its state? A stateful set is useful for applications that store data, like databases. So if you have any application that is going to store data, a stateful set is going to ensure that those applications, the data is not lost. Even if the application stops running, the data is not lost. But for a deployment, whatever data was saved in this deployment, if I delete this port and recreate it, the data is lost and the port is recreated and the port comes up new and fresh. So if you want an application that maintains state or that keeps data, you use a stateful set. If you want an application that does maintain high availability, you use a deployment. If you want an application that should run on every node, you use a deployment, a daemon set, sorry. So let's try to create a load balancer type of service here and see if we lb svc.yaml. So let's try to create a load balancer type of service. If you look here, if you're wondering how what to do, there is this repository that shows you the steps to create a deployment and a service to expose that deployment. Let's try to create a load balancer type of service. So here we'll call it load balancer or service, sorry, service, and it's Kubernetes service complete. So here we're looking for a service of type load balancer. So the name of the service is going to be Kubernetes, multi-color load balancer SVC. And label, we must use the same label, load balancer. This for the deployment. I have to rename this to load balancer. And I open on the site. So the label here was app is equals to multicolor. So we must use the same label here. App equals to multicolor. The type of service is load balancer. And the name is use LB or TCP, doesn't matter. The port is port 80, the target port is 8080. So to confirm this configuration, I have here, let me duplicate this stuff. I have another repository here for Kubernetes. Terraform. I'm looking for service of type load balancer, deployment, replica set, stateful set, daemon set, service discovery. This is cluster IP, node port type of service, and then load balancer type. So this is it. The load balancer type of service. So this is okay. So we'll do kubectl ls kubectl apply -f load balancer type of service.yaml kubectl get svc. Okay, perfect. So you see, it creates a load balancer for us. This is the load balancer URL, and the load balancer port is port 30,556. So it has created a load balancer for us. If you look on AWS now, under load balancers, you should see it's in the process of placing the load balancer for us. So it will take some time for this load balancer to come up active. DNS name, 0 out of 4 in service. Classic load balancer can be migrated to the next generation wizard. This has created a classic load balancer for us. And then for security group, this was a security group. Inbound rules 31,200. One added this rule. Already inbound rules. And believe this, and the one added this rule. Let's see what is happening with the load balancer. I'm not sure why it's creating a classic load balancer. Yeah. So we see we can access our application, right? By means of a load balancer, we're able to access our application. Now, if I do something like this, kubectl get ports, kubectl get ports. We have the 3 ports running. If I do kubectl logs -f, and I want to lock this particular port, when I put -f, I mean it should be live logs. So if I keep refreshing here, so this takes me to another website, but this is our website essentially that we have created. So we're able to access this website by help of a load balancer. So our application is live, and we have used a deployment, kubectl get deploy. We have used a deployment to access our application. There are 3 replicas of this application running. The good thing with the deployment is that you can scale this deployment. So you can scale deployment, multicolor deployment to 5 replicas or maybe to 10 replicas. So if you do kubectl get ports, what do you see? Now 10. 10 of them are running. You can scale to 0. If you do kubectl get port, you see they are being killed. You see all of them in terminating state. So this is the flexibility that Kubernetes gives you and Kubernetes deployment gives you. And all of this is giving you the advantage to use a load balancer. Gives you the possibility of using a load balancer. So we're using a load balancer to perform this action.
Question, Prof.
Yes.
When you scale it to 0, is there a possibility for you to revert? I thought
Yes.
I thought it was not possible to scale it to 0 because we have to have a safety backup.
Yes. Okay, now I've scaled it to 0, right?
Yeah.
If I do kubectl get, I've scaled but the port to 0, kubectl get deployment. Do you see my deployment?
Yeah. Yeah.
Okay, kubectl get kubectl get stateful set, replica set. If I do kubectl get replica set, what is the desired?
0.
I'm the one who desired 0.
Okay.
But now let me desire something else. So I can scale back up to 5.
Okay. Okay.
So if I do kubectl get replica set now, what is my desired now?
5.
5. If I do kubectl get port, we're back at 5.
5. Okay. Thanks.
Okay.
Yeah. So the only way I can do away with this our deployment is if I delete the deployment itself.
Deployment at all. Okay.
Yeah, that's when everything goes. But if anything happens to this pod, they get recreated. So long as my desired is 5, the replica state is going to always try to make sure that I have 5 running. That's the beauty in Kubernetes. So this is a deployment. This is a pod. So I've done the Terraform configuration file. What have we achieved? We've been able to come up with the Docker file for our application. And in this class, we've added the file for Terraform. This is the deployment manifest file. This is the pod manifest file. And this is the application manifest file. To deploy this application, this is the application manifest file. So it's very important to note all these small things that we have done. So I'm trying to I will take time to understand Kubernetes IO role, Elastic Load Balancer. Yeah, we created this. So I'll try to find out why in our cluster configuration, we don't have a public IP address. Release version, VPC site. Enable port ENIT standard. Okay. If I do Terraform and not in this directory, cd into Terraform, and I do Terraform plan. Let me see if it's I want to destroy these resources we have created. It will be Terraform destroy. So I want to pull down the resources we have created. Do you want to destroy? Yes. So